Hello class, welcome to section 13.2. We're specifically reviewing the fundamental counting principle. The main, and this was kind of hinted at in this section 13.1, the basic premise is that if we have so many choices of, or so many options in a certain situation, the total number of options that we have is given by the product of the total number of choices that we have. So for example, you have 7 different shirts, 4 pairs of pants, 3 pairs of shoes. How many combinations of outfits can you have? It's a matter of multiplying the number of choices that you have. 7 times 3 times 4 is 84. As I said, this is the fundamental counting principle. You can choose m items from one group, n items from the other. The total number of choices is n times m. So a couple of examples. How many ways can you flip 5 coins? So we consider each flip a particular event. Each time we have 2 choices, for heads or tails. So 2 times 2 times 2, 5 times is 32. How many ways can you roll 3 dice? You have 6 choices each time you roll dice, or a die I should say. 6 times 6 times 6 gives me 216 possibilities. There you go. How many combinations can you have for a license plate with 3 spaces for letters and 3 spaces for numbers? Well, for each of our three letters, we have 26 possibilities. Of course, 26 letters in the alphabet. So each time, assuming and again, it didn't say that we can't repeat items. So if we can repeat them, which we can assume we can, otherwise, it would have said otherwise. Each time we have 26 choices, so 26 times 26 times 26. Then for each of our numbers, we have 10 possibilities, 0 through 9, 10 times 10 times 10, and it comes out to be 17,576,000 possibilities. How about a long one? In the early part of the 20th century, the Austrian composers Arnold Schoenberg, Alban Berg, and Anton Webern created a system of music called atonal music, which a note cannot be repeated in a composition unless all the notes are used. In atonal music, a melody called a tone row consists of a sequence of 12 different notes. How many different tone rows are possible in this system? So we have 12 different notes, and a note cannot be repeated until all the notes are used. So that's where I was referencing earlier. So if we have 12 different possible notes, each time we cannot repeat a note until everything else has been used. So the first time we choose a note, there are 12 possibilities. Now if we can't repeat notes, whatever note we chose that first time we can't use again. That means there's 11 possibilities. Same thing again. We've used 2 notes. That means there's 10 possible notes left over. So it's 10. And then continue it down, 9, 8, 7, so on, down to 1. Which comes out to be about 479 million possibilities. Using the digits 0 through 9, to determine how many of each type of 4-digit number can be made, if 0 cannot be used and numbers cannot be repeated. So using those 10 digits, how many numbers can be created in a 4-digit number if you cannot use 0? I should edit this with me. If 0 cannot be used for the first number, just realized that I didn't put that in. If 0 cannot be used for the first number, and numbers cannot be repeated. So if we look at this, if we can't use 0 for the first number, that means we have 9 choices for our first number. 9 out of 10. Now numbers cannot be repeated. So if we use 0, it means we can't use 0 anymore. So we still have, again, 9 choices. And then if we use 1 or whatever we chose for that second number, we can't use it again. Now we have 8 choices, and we have 7. So that comes out to be 4,536 possibilities. Now this, and that's just extra space that I didn't delete. This sums up the section on section 13.2. This is the fundamental counting principle. Again, the basic concept is however many choices that you have for a particular question, multiply them to total number of choices times each other, and that's your total number of possible outcomes. So, as always, if you have any questions, feel free to contact me, and have a good day.